Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This time I'll talk a bit about using shift registers to cut down complexity, hunting a latch-up bug in logic modules, simulating electronics using SPICE or QUCS, a Nanoloop 2 cartridge, repairing stuff, and some other non-tech hobby stuff. Hello and welcome back. A friend of mine told me recently that it had been 3 weeks since the last episode came out. Now, the reason for that is not that I'm getting bored of this podcast at all, it's still a lot of fun, but that I haven't been doing a lot of technical stuff for the last weeks. It's more work stuff and boring administration stuff and a bit of other hobby stuff. So, this episode is going to be quite short because I don't want to talk about the other stuff because that's not what this podcast is about. Last time I talked a bit about the digital logic boards for my CPU project. Now I finished all logic boards, they all arrived, I assembled them all, tested them all, and in principle they work. However, I'm chasing a bug right now, just continued with that and still didn't find it, having to do with, I think, a latch-up in one of the I/O boards, and I think it's on all the I/O boards. And what happens is, when power is not sequenced properly, in other words, when you take a plug-in module and you just jam it in the breadboard with power connected, so it's more or less random which pins are connected first. At least that's what I think. There are certain chips on there. It's the Texas Instrument SN74LVC06A, which is a hex inverter driver. And I use that IC to drive some LEDs. So you have an output, and instead of just having to measure the output with a multimeter as a user, you have a LED on the logic board which shows you the value of a bit, basically, the value of a line. So it is all fine except one out of every so many times that you connect it on the breadboard. It pulls a lot of current, and I can see with the infrared camera that one of the driver ships, there are typically 3 or 4 driver ships on one board, and one of the ships gets hot. So basically that's the one dissipating all the power. That's not good. And I think it has to do with latch-up. To be honest, I know basically what it is, but I'm not really, I don't know too much about what goes on actually inside the chip at the junction level. So I don't know if I can debug this. I put it on the scope just now, try to see what happens at the inputs and outputs of the chip with respect to the power supply line. It's not really clear. Then I tried a quick fix, which is to put Schottky diodes in between the power rail and each of those chips to prevent current flowing back from an I/O pin through a clamp diode in the chip to the power rail, which can be a cause of latch-up if the current is significant, let's say more than 100 milliamps or 200. But unfortunately that didn't help. So would have been nice to have a nice success story here, but we're not there yet. So I don't know what to do now. Maybe ask around or take a good look at the schematics or read up on theory to get some clue. No idea. Now in practice, so what I would like to do, actually what I must do for the upcoming Maker Fair in Dortmund, that's I think 10 and 11 March, is finish all the boards. Finish a baseboard and have some kind of enclosure and software, so that's quite a lot of work. And what I can do is just make the logic boards as is with this bug still existing. But it's a controlled environment, so you don't plug them into a breadboard randomly. You just power the whole device up with all the boards sitting nicely in their sockets, so there's no weird power sequencing going on. It's all very nice, and that will work, but the problem still exists, so I'm not sure if I should solve it now or solve it afterwards. We'll see how that goes. The existing baseboard, again with a CPU project, basically consists of a big fat microcontroller with a lot of I/O pins. I think it's a 100-pin device or something like that. And I drive everything in parallel. So interface with CPU's address and data bus, in a parallel fashion. So read and write all the lines at once. And I don't know if that's a very smart solution, but for the next time I want to do a lot of the stuff with shift registers. So there's a lot more I/O going on, so it would be a bit ridiculous to do it with a microcontroller and do everything in parallel. So it makes a lot more sense to use a lot of shift registers and a relatively small microcontroller, at least one with not too many I/Os, and just do everything in serial. Should be fast enough. And also drive the display in serial. Should be very easy, very straightforward, and it should just work. Famous last words. Now, I want to talk a little bit about simulating electronics and circuits. I don't do this very often, but when I do simulate small pieces of circuits, I usually type them in SPICE, syntax, and then run ngSpice to simulate it. A graph, which outputs a graph, basically plots a graph of current or voltage and whatever. But 2 times these are really super simple circuits that I use, so you can type them in by hand. It's just basically a net list, and you define which components sit between nodes, and it's all fine. However, for the last 2 times I've been using the quite universal circuit simulator, which is QUCS, QUCS, or CUCS, no idea. And it works nicely, actually. So it's semi-intuitive, and I only use it once in a blue moon, but still I don't have to look at the manual, it just works for the stuff I want to do with it, which is very simple, so that works great. So there's a piece of a filter you can simulate very nicely, or a piece of a power supply, you can simulate it really nicely, so saves a lot of time. So I'll put a link in the show notes for both of the ngSpice and the QUCS. Should be nice tools. Now, something not technical related, I'm not going to talk about it long because it doesn't belong here, is I got a Nanoloop 2 music making cartridge for the Game Boy Advance, and I've been playing a little bit too much with that. And it's very easy to make sounds like this, basically. And it's a little bit addictive. So make a bit more, but once the enthusiasm goes away, then it will become less. Also, last weekend I've been repairing stuff at the retro computer place in the middle of the Netherlands again. Not so much repairing. The plan was to fix a Nintendo Entertainment System, which had the curious bug that when you turn it on, the colors are fine. After a few minutes, colors go black and white plus fuzzy, basically. And after half an hour or 45 minutes or something like that, the colors come back. So I don't know what it is. So another guy suggested some debugging, some ways to debug that. I'll have to try that. But other stuff got in the way, so I didn't fix that. I fixed something else. But it was a very nice experience, so I'll go back there next month. Now, that basically was it. For the rest of the hobby stuff, I've been doing drawing with pencil and color pencil and oil pastel stuff. There's that. And also been doing a German course. And partly that is to be able to say what I want at the upcoming maker fairs and so on in Germany. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.